Hello, in this video I'll be talking about the next task for generating the second input file from the output of PACML. So PACML generates a file called p4_/pdb, which you can see on the screen here. You want to convert this output file to a file which looks something like this. So I'm going to walk you through the steps that needs to be done in Python to generate the second input file, which is called data p4 water random txt. Okay, so going back to output of PACML, this output has some blocks. The first few lines are some comment lines that need to be ignored. The next block actually starts from the keyword het atom, which stands for heterogeneous atom. So we want to convert this block, which starts from this line, all the way to this line, which starts with a keyword connect. So this block, which we talked about, starting from heterogeneous atom, needs to be converted into something like this. So this second input file has a comment line, which doesn't really matter what that is. So for now, let's keep it as water MP4 on SiO2 slab. Then you leave a blank line. The second line here is going to be the number of atoms in the first output file here. So this number, which is right now is 7,124, is supposed to be the number of lines. Okay, the number of lines there. Oops. The number of lines that starts with heterogeneous atom keyword. So if we have, let's say, 400 something like 27 here, 428. So then, so the number of atoms in the second input file here should be 428. Okay, so exactly the same number that you see here. So that's about this line. And then the next line is the atom types. This 6 is coming from the type of atoms in this block again. So you have to go back to this file and then look at the third column here and then see how many atoms we have. H stands for hydrogen, O stands for oxygen. So far we have only two types, hydrogen and oxygen. But if you go down, other atoms will show up. Like in line 403, we see carbon, C stands for carbon. And then again oxygen, fluorine, F stands for fluorine, and then down here hydrogen again. So the carbon, oxygen, and hydrogen, and fluorine in this block, which looks a bit larger than the block above, needs to be counted as different atom. So this oxygen you see here will be different than this oxygen because the fourth column is different. The fourth column here is HOH, stands for H2O, that's water. But below that we have U and L stands for something like I believe untitled or something like that, something like unknown compound. So the oxygen that comes from unknown compound will be different than the oxygen that comes from water. In that sense, hydrogen would be type 1, oxygen would be type 2, and let's say carbon is going to be type 3 atom. This oxygen is different than that oxygen, so it's going to be type 4. Fluorine is going to be type 5. We already counted carbon. And then we have hydrogen here, type 6. So overall, we have 6 types of atoms. That's why you see 6 here. When we leave a blank here, the next block is called masses, so you have to type this masses exactly. Then we're going to have a block with mass of every atom. So remember, we had 6 types of atoms: hydrogen, oxygen, carbon, fluorine, and oxygen of the second block I talked about, and then hydrogen of that block. So these are the masses that we extracted from periodic table. You don't have to dig into any details. You just type these masses exactly in this file. So again, this file needs to be generated by the Python code from this output file, which is the output file of PACMO. Okay, going back here, the next block is atoms. Again, you leave a blank line and then atom section, then another blank line. And here we're going to have the coordinates of all those 428 atoms in the output of the PACMO here. The coordinates are column 6, this is column, column 7, 8, and 9. These three columns will be copied over to these three columns. The first column here is going to be the index, start from 1, and it should go down all the way to 428, exact same number we had there. But now in this one, in this example I'm showing you, it's about 7,000. So if you scroll down, you're going to reach to 7,127, I guess. But going back to the beginning of it, the first column is going to be the index, the second column is going to be the atom type. Again, remember, the first line here, if it's hydrogen, okay, the first line here is going to get the index 1 in the second column, stands for atom type 1. Going back here, let's say the second one is also hydrogen, and then the third one is oxygen. So it's going to be, again, atom type 1 because the second one is hydrogen, and then the second one is going to get type 2 because that is oxygen. So you see these numbers in column 2 correspond to the atomic symbol in the third column here. So there's a one-to-one correspondence, and the correspondence actually comes from this table right here. Okay, the third column needs to be all 0, and then the fourth, fifth, sixth column would be identical to 7, 8, 9 column here, which are the coordinates. So that's all about generating this data P4 water random txt out of P4 slab PDB, which is the output of PACMO. If this can be done in Python, then Python is going to generate the output file from PACMO, and then it's going to convert that into this input format that we have on the screen. That is the end of it. So basically, if you go down to 7,000 lines here, it's going to be the end of this block, and there's nothing after that. So I have to quickly scroll down to get to 7,000 lines there. So let's say this has to be 7,124, yeah. So and overall we have 6 types. You see that sometimes you get atom type 6, which stands for hydrogen. Okay, so again, in the PACMO output file, the only block that would be useful for us is going to be this block, starting from heterogeneous atom here, all the way to the line that starts with connect. So yeah, okay. Right, so one last thing is, remember the atomic symbol within the line which has U and L in column 4 will be different than the atom, same symbol actually, in the section that has HOH in the 4th column, okay? As an example, this O with HOH symbol in the 4th column will be different than this O with U and L in the 4th column. So this will be type 2, this will be type 4, according to the table we had up here. I'm sorry, so the first one, which is HOH, the oxygen of HOH get the type 2 atom, and then the oxygen of the one that has U and L in the 4th column here is going to take type 5. Okay, so with that, I hope you will be able to generate this data P4 water random txt out of output file from PACMO. Thanks all for watching. Stay tuned for the next video on other tasks for this internship.